Hello, good morning, and a very warm welcome to HDR's Talk of the Town. As always, so lovely to see familiar faces and close industry acquaintances in the audience. Absolutely super to have you here in our London office I was going to say on such a pretty autumnal morning, and yep, the sun is about to peek through. My name is Farah and I'm the Global Marketing and Communications Director for Building Engineering Services as part of the HDR family. Before we learn about our thought piece, carbon offsetting, a band-aid or a solution, and whether our industry should be embracing circular economy principles, I would like to share a short potted history about our speaker this morning. Born and raised in Essex, Steve fell into engineering by accident. Albeit he studied medical engineering at Queen Mary, London, he actually aspired to become a stockbroker. After graduating, Steve secured his first role with a finance company looking at mortgage shortfalls and compensations leading up to the time when the Lehman Brothers would file for bankruptcy in 2008, and we all know what happened then. An interesting time indeed. Rather ironically, the beautiful building just behind me is actually where Steve had his first job, in the not so beautiful building. So clearly he has a love of this location here in Bankside. Working in this role for 10 months, he took the summer off to coach aspiring footballers in the US. Upon his return to England, he decided he would put his engineering to good use and secured a role at BDP, a multidisciplinary architecture and engineering consultancy. Steve's father, an electrical engineer by profession, in the background would always quietly encourage Steve to be an engineer, and this advice finally paid off. Steve was at BDP for 5 years, and one of his most notable projects was one of the offices for PricewaterhouseCoopers at Moore, London. Steve moved on to join Buchanan Hartley and was seconded to support Grange Hotels. At the time, Grange Hotels were one of the largest independent hoteliers in London. Steve was the lead mechanical engineer for 100 Minories, now known as Tower Suites Hotel. Steve joined HDR as an associate in 2018. Since joining our company, he has specialized in leading projects from design through to delivery. Most recently, Steve led on the elegant Beaumont Hotel in the heart of Mayfair. He is also leading on Vintners Place and office development on behalf of Greycoat. Steve has also worked on projects abroad, namely La Petite Maison and Malmo in the Kingdom of Saudi Arabia. In his personal time, Steve is married and a father to a 6-year-old little boy and spends his time coaching his son's mini soccer team. Steve also loves to travel with his family, and when he finds time, enjoys playing golf. In his current role, he also helps to support our wider business development efforts, as well as leading on the engineering, design and delivery of projects. Steve brings a healthy mix of experience across many building typologies and has always been curious to learn more about how our industry will eventually transition to net zero. And so, without further ado, I'm absolutely delighted to introduce the super charming Steve Bonnet. Thank you.
Good morning, everyone, and thank you, Farah, for that kind introduction. Delighted to be here today to share my thoughts with you on a highly topical subject. Although I must confess that when I was sitting in the audience for our first Talk of the Town, where Melissa spoke so eloquently, I remember thinking, I do not envy the next person that Farah will work with. Little did I know I was going to be that next person. So to help set the scene, I'd like to read this quote from Robert Swan. "The greatest threat to our planet is the belief that someone else will save it." I'm going to begin today with a short history lesson. The first carbon offset can be traced back to the late 1980s. In 1988, Applied Energy Services approached the World Resources Institute for advice on how to mitigate its impacts that its coal plants have on the climate. The advice from WRI was for AES to fund an agroforestry project of planting trees in Guatemala, with the intention that these trees would offset emissions from their first coal plant. This was considered the first ever land-based carbon offset project. For clarity, carbon offset credits are permits that allow the owner to emit a certain amount of carbon dioxide or greenhouse gases. One credit allows the emission of 1 tonne of carbon dioxide or the equivalent of other greenhouse gases. Carbon credits are also known as carbon allowances. Firstly, it's important to understand that carbon offsets and renewable energy are closely related, but yet they serve different purposes. Whilst both strategies are used to reduce greenhouse gas emissions, they operate in fundamentally different ways. Renewable energy is a type of energy generated from sources that are naturally replenished over time. These include solar, wind, hydro, and geothermal energy. By using renewable energy, individuals and organisations reduce their reliance on fossil fuels, which are a major contributor to greenhouse gas emissions. Carbon offsets are credits that represent a reduction in greenhouse gas emissions. They can be generated through various activities, such as planting trees, investing in renewable energy projects, or improving energy efficiency. Individuals and organisations can purchase carbon credits to offset their own emissions, effectively neutralising their own carbon footprint. Now, the connection between the two lies in the fact that many renewable energy projects can generate carbon offsets. For example, a solar or wind farm that produces renewable electricity can also generate offsets, as this reduces the need for fossil fuel powered electricity. In summary, renewable energy directly reduces greenhouse gases by providing a cleaner alternative to fossil fuels. Carbon offsets, on the other hand, are a way to neutralise emissions that cannot be avoided. While these are not a direct substitute for renewable energy, carbon offsets can be a valuable tool for achieving carbon neutrality, especially in the short term. Now, to put this into context, a single tree will typically absorb around 10 kilograms of carbon for the first 20 years of its life. And once fully matured, we would expect a tree to absorb around 21 kilograms of carbon dioxide each and every year after. Last year, in the US alone, circa 2.7 million acres of forestry were destroyed by wildfires. With a conservative estimate of 100 trees per acre, this equates to 270 million trees being destroyed, with each tree having the capability of removing approximately 21 kilograms of carbon dioxide. This resulted with a loss of potential of removing 5.7 million tonnes of carbon dioxide from the atmosphere in the US alone last year, which I hope you all agree is a significant amount. I'd now like to invite you to read this quote from French businessman François-Henri Pinault, who helps to contextualise the relationship between carbon offsets with business. As I've explored this topic, the question that I will ask is, should we be for or against carbon offsetting? The appropriateness of carbon offsetting in 2024 is a complex and debated topic. Whilst this approach can be a valuable tool in reducing overall greenhouse gas emissions, there are several factors to consider. The arguments in favour of carbon offsetting: it can be used to supplement other measures, such as reducing energy consumption and transitioning to renewable energy sources. Many offset projects contribute to sustainable development goals, such as poverty reduction and biodiversity conservation. And in some cases, carbon offsetting can be a more affordable option than making significant changes to existing operations. However, there are some criticisms of carbon offsetting. There is a risk of double counting emission reductions if they're claimed by both the offset project and the entity purchasing these offsets. The quality and effectiveness of offset projects can vary widely, and there may be challenges in verifying emissions. And there's a potential for greenwashing. Some companies may use carbon offsetting as a PR tool without making significant changes to their operations. Whilst researching this topic, a quote which particularly resonated with me was one by Desmond Tutu. 25 years ago, people could be excused for not knowing much or doing much about climate change. Today, we have no excuse. So following on from this, I'd like to share some interesting facts. Which countries offset the most carbon? Whilst the countries with the highest carbon footprint are China, the United States and India, with a cumulative share of over 50% of the world's carbon dioxide emissions, Europe is typically the largest buyer of carbon credits, with the European Union's emissions trading system accounting for 87% of the global carbon market in 2023. As the practice is widespread and often not publicly disclosed, identifying countries which do not use carbon offsetting is challenging. However, some countries have explicitly banned or discouraged the use of carbon offsets as a primary strategy for climate mitigation. Examples of countries with such policies include Norway, which has a strong focus on renewable energy and has been critical of the effectiveness of carbon offsets, particularly those involving tree planting, and Denmark, which has a long-standing commitment to renewable energy and has expressed concerns that the potential for carbon offsets may be used as a way to avoid domestic emission reductions. So this leads me into which sectors offset the most. The industries which offset the most carbon are typically those with the highest carbon footprint, and these include energy, oil, gas, power generation, transportation, aviation, road transport, shipping, manufacturing, industries like steel, cement, chemical production, agriculture, livestock farming and agricultural processes contribute to the emissions of methane and nitrous oxide, and finally the construction industry. We've seen in the press recently the new government has pledged £22 billion for carbon capture projects over the next 25 years in Teesside and Merseyside. This technology is designed to capture the carbon dioxide generated in manufacturing processes or energy production, such as a gas-fired power station or a hydrogen plant, and storing this carbon deep underground permanently, effectively removing it from the atmosphere. This has already received some criticism from the likes of Greenpeace and Friends of the Earth, suggesting that this kind of process would only extend the lifespan of the fossil fuel industry. In 2023, 164 million carbon offsets were purchased and retired. This was a 6% increase from 2022. The biggest purchasers of carbon credits in 2023 included the likes of Shell, Volkswagen and Audi. Before we move on, this quote in particular struck a chord as we was researching our talk. It angers me when sustainability gets used as a buzzword. For 90% of the world, sustainability is a matter of survival. Closer to home, the question we ask is, how is this relevant in our industry? In October 2021, the UK government published its net zero strategy with the intention of setting out a pathway to reaching net zero greenhouse gas emissions by 2050. According to a RICS report on decarbonising UK real estate, the built environment accounts for around 30% of total annual carbon emissions in the UK. This carbon comes from two sources, embodied and operational. Most of us are familiar with the concept of operational carbon, the carbon used in operating and using a building. This includes things like lighting, heating, ventilation, cooling, and general power usage throughout the building. The operational carbon footprint is the sum of all the carbon produced over the lifetime of the building, which for whole life carbon analysis is typically 30 years. We are all aware of the London Plan energy hierarchy and the requirements to report estimated site-wide regulated carbon dioxide emissions at each stage of the hierarchy of be lean, be clean, be green and be seen, by undertaking energy assessments as part of our planning submissions. Under current guidance, the GLA require a minimum 35% improvement beyond Part L 2021 for regulated carbon emissions, with a maximum permissible offset levy of the remaining 65% to achieve operational net zero. The current cost of this is £95 per tonne of carbon dioxide. Embodied carbon is the carbon footprint of a building before it is built and encompasses the greenhouse gases emitted during the construction process. This includes aspects such as extraction and production of materials, transportation of materials, manufacturing, construction, demolition and retrofitting, and end-of-life deconstruction. Embodied carbon can be considered to be the upfront carbon that is generated before the building is used. As mentioned, 30% of annual CO2 emissions come from the built environment, and 10 to 15% of those come from upfront or embodied carbon. Over the last 50 years, architecture, engineering and the construction industry has focused on making buildings more energy efficient. This, coupled with the decarbonisation of the grid, has resulted in buildings that are using less energy overall, and the energy which they are using is now coming from a cleaner source. Making buildings more energy efficient and electrifying schemes with the removal of gas plants has lowered their carbon operating emissions. As a result of the operational carbon being reduced, embodied carbon will account for a larger percentage of total carbon. If we were to fast forward to a time when the grid is completely powered from renewable sources, the carbon factor for electricity would be neutral. Then the only carbon within an all-electric building would likely be embodied carbon. Canada, Sweden and Norway are already seeing a 50-50 split of embodied carbon versus operational carbon. This is because these countries have made a conscious effort to move away from the use of fossil fuels and move towards renewable energy. We need to start paying more attention to embodied carbon now if we want to make a difference in the future. So panning back out to a UK level, how is embodied carbon regulated and assessed? Whilst currently it's not a legislative requirement, whole life carbon assessments have been common practice as part of the GLA and local borough planning requirements for a number of years. These assessments consider the carbon emissions associated with a building's entire life cycle, from extraction and manufacturing of materials to its construction, operation and demolition. This holistic approach helps identify opportunities for carbon reduction throughout the building's lifespan. Several building certification schemes, including BREEAM and LEED, now mandate or strongly encourage whole life carbon assessments to evaluate a building's carbon footprint throughout its entire life cycle. In addition to this, a new building regulation, Part Z, Whole Life Carbon, is currently under consideration, with the latest revision issued January of this year. This proposal outlines the requirements to make whole life carbon assessments mandatory and limiting embodied carbon for all major building projects. With a proposed staggered approach to start in January 2026, the intention is to normalise the use of whole life assessments within the building design process. In the early stages of this new regulation, it is anticipated that whole life carbon assessment results will be stored to create a database of various building types, which in time will allow maximum embodied carbon limits for various building typologies to be set, which must not be exceeded, with a view that these limits will be reviewed and reduced further every 3 years. The second part of my talk this morning is to explore how the circular economy can make a meaningful difference to reducing carbon emissions. If it can't be reduced, reused, repaired, rebuilt, refurbished, refinished, resold, recycled or composted, then it should be restricted, designed or removed from production. A quote from Pete Seeger. As you can imagine, the circular economy offers a powerful framework for reducing carbon emissions. Principles which are considered to contribute to this goal include design for demanufacturing, design products and structures with easy disassembly in mind, allowing for components to be reused or recycled. Avoid toxic materials, minimise the use of harmful substances that can contaminate recycling streams. Promote reuse and refurbishment. Extend lifespans of buildings by investing in maintenance and upgrades to prolong their useful life. Retrofit for efficiency. Implement energy-saving measures in existing buildings to reduce their own carbon footprint. And reuse materials. Incorporate salvaged or recycled materials into new projects by using the likes of cross-laminated timber or reclaimed steel. The Institute of Structural Engineers estimates that between 40 and 80% of the UK's construction steel section demand could be met by using reclaimed steel from deconstructed buildings. This reclaimed steel has a carbon intensity value as low as 50 kilograms of emitted carbon dioxide per tonne, compared with a sector average of 1,740 kilograms. A big difference. Third point, encourage recycling and waste reduction by developing recycling programs and establishing efficient systems for collecting and processing waste. Optimising production processes to minimise waste and explore the use of recycled materials in new products and structures. Foster collaborative partnerships by creating material banks for sharing and exchanging materials between businesses. Encourage modular construction techniques to facilitate reuse and reassembling of components, and promote circular supply chains by working with suppliers who prioritise sustainability and circular practices. And finally, invest in research and development. Support research into new sustainable materials with low carbon footprints. Invest in technologies that enable more efficient resource use and waste reduction. By embracing these principles, businesses and industries can significantly reduce their carbon emissions, contribute to a more sustainable future and drive economic growth. I'm going to read a quote from Angela Merkel, the former Chancellor of Germany. "We must now agree on a binding review mechanism under international law so that this century can credibly be called a century of decarbonisation." So moving on, what do we mean by a net zero building? A net zero building is one that produces as much renewable energy as it consumes over its lifetime, effectively neutralising its carbon footprint. Whilst operational carbon is a significant factor, as we touched on earlier, embodied carbon, emissions from materials and constructions, is also crucial. To determine whether a development in London meets net zero standards, a comprehensive assessment is typically conducted, which involves evaluating both operational and embodied carbon. Just last month, the first pilot version of UK Net Zero Carbon Building Standard has been implemented. This standard has been developed by a cross-industry group representing stakeholders across the built environment to develop a standard which defines the requirements for a building to be classified as truly net zero. This standard covers all of the UK's building sectors, providing a clear set of requirements for buildings to be able to be classified and marketed as net zero. Importantly, this is an in-use standard, meaning that buildings can only claim to be net zero carbon aligned once they've been occupied and in use for at least a year, with measured in-use building performance data. Here's a breakdown of the key factors considered. Energy efficiency. The development must comply with UK building regs which set the minimum energy efficiency standards. The building should be achieving a high EPC rating, an A or a B, and on-site renewable energy generation will be required, such as solar panels, wind turbines. They're often required to offset a significant portion of the building's energy consumption. Embodied carbon, material selection. The choice of materials with lower embodied carbon, such as recycled materials or those made from renewable resources, is crucial. Construction methods. Efficient construction practices that minimise waste and energy can also reduce embodied carbon. Once this has been taken into account, a net zero calculation is undertaken. The total carbon emissions from both operational and embodied carbon are calculated. The amount of renewable energy generated on site is also assessed. And where necessary, the amount of carbon offsets purchased are added to this calculation. The total carbon emissions are compared to the renewable energy generation and carbon offsets. If the emissions are equal or less to the total renewables on site and offset credits purchased, the development is considered to be net zero. Now, my question to consider, is it appropriate to be awarded this UK net zero carbon building if offsets have been purchased? Or should there be a differentiator between a development which has achieved net zero with and without the use of offset credits, maybe a gold or silver standard? So to wrap up my thoughts, embracing this circular economy can contribute significantly to achieving net zero. Yet this approach is not a guaranteed solution on its own. The circular economy is a powerful tool for reducing carbon emissions and contributing to a net zero future. However, it's essential to combine circular economy principles with other strategies to achieve a sustainable and climate neutral world. Renewable energy directly addresses the root cause of climate change by transitioning away from fossil fuels, while carbon offsets offer a way to indirectly reduce emissions. While both strategies can play a role in combating climate change, renewable energy is generally considered a more sustainable and effective long-term solution. Whilst there is a place for carbon offsets, we should be doing everything possible to reduce operational energy first, with carbon offset a final resort, which we may argue is the principle behind the London Plan. When thinking about the London Plan specifically, should the levy of £95 per tonne of emitted carbon dioxide cost be increased, maybe to drive us harder in order to design buildings more efficiently and effectively? Is there a temptation to just do the bare minimum and maybe pay the fee? What more can we be doing? When undertaking new developments or refurbishments, should we be installing ceilings, carpets, lighting, only for the possibility of them to be thrown away when a tenant arrives? Would a shell and core provision be more suitable? We are seeing more and more of this. But should this just become the new normal? Should agents be made more aware of the significance of embodied carbon and upcoming regulation changes? As an industry, if we do not adopt these trends, we may find there will be issues with financing future projects. It was reported in the press that ING have warned 2,000 of their clients, which include real estate developers, that they would impose stricter financial conditions or walk away from clients failing to demonstrate sufficient progress in the transition to net zero. To finish, I'd like to share with you part of an article I read recently from Andrew McDonald, Managing Director of Real Estate at HSBC. Greener buildings already command a premium from investors and occupiers, and this trend will only gather pace. Construction processes and embodied carbon are key to understanding the whole life impact of any building, and we can expect this growing awareness to reshape the entire value chain over the coming decades. Clients that recognise this new reality will ensure they are left with the most valuable and long-term sustainable assets, while simultaneously helping the industry transition to net zero. Thank you very much for listening. I'd be interested to hear your thoughts.
Steve, thank you very much for that. Really insightful. There's a lot of data you've just thrown at us, clearly, and it's obviously a big topic. What I'm interested in is, obviously, you've talked about regulation, talked about guidance, talked about incentives, arguably, with offsetting. Which of those, in your respect, is kind of the balancing factor, the push factor?
I think it's going to be regulations, partnered with the investors demanding low carbon and high performance buildings, in addition to tenants requiring low environmental impact workspaces, which will lead to a step change within the industry.
I just wanted to validate what Steve was saying about regulation being key. I think when you look globally, it is the countries that have had the regulation that have made the most progress there.
Is it currently possible to deliver a net zero building without carbon offsetting?
So Holbein Gardens over by Sloane Square is a net zero office building, and so that retained a lot of the structure, which really helped with the embodied carbon. The new floors were constructed out of CLT and reclaimed steelwork, and so that brought the sort of kept the embodied carbon low, and then the operational energy was sort of really worked on to make it a mixed mode building that used VRF, heat recovery, PV panels, but also openable windows that turns off the air conditioning, and so managed to get sort of a 90 kilowatt hours per metre squared energy intensity for it. So the idea was to sort of pull it down without sort of carbon offsetting. I'd have to check into the if there was any carbon offsetting at the end, but I think it was a small contributor to it. But it meant that the whole team had to look at everything that could be done for the building. This included sort of speaking to the agents early, Knight Frank, to get their input to it, and also the tenant in terms of what finishes they were looking to change, and so they're not putting in certain finishes in reception in the showers, so that they're not pulled out and reinstated. So it was it followed the whole life carbon circular economy principles from the outset, and I think any sort of project going forward has to do that to pull down the carbon intensity.
it's sometimes useful to stand in the solution and look back at the problem. So, for example, in developing commercial buildings particularly, but also residential buildings, particularly in cities, land prices are very high. That forces us into very intensive use. It drives us towards deeper basements. Deeper basements are consumptive of carbon because of the materials and the methods of construction. So I don't offer a solution, but there's some sort of spiral knot up of thinking there. We've tried to get away from offering plants some of the best views in London by burying the plant underground, taking advantage for the people and the users of the views. So there's that sort of conundrum that we've got to solve. And I think regulation has its part to play, but this is a journey, not a destination. So I think we've sort of all got to hold hands and walk along the line together. It's a rather philosophical view. It's a very, very complicated issue and is very site-specific. That's the kind of problem that we face as a developer.
I think what you've cited is a clear example of the type of building we're seeing, but also just a broader point, and maybe help take the audience to consider this as well, is the role that ESG has to play. And Steve, you touched on this in your talk as well, in terms of investors and where the developers ultimately are attracting investment from, and then how that money is being traced as well into clean investment. So I'd like to pass that back to the audience. And Steve, back to you as well.
Me first? No, I think it's a really powerful tool coming from the investors. So I think legislation, it's almost what we spoke about earlier, is going to be number one. But if the investors are on board who's providing the funding, again, there won't be any developments if they stick to that sort of hard line. So I don't think it's going to be black and white. I think it's going to be sort of sequential, progressive steps to get there.
I would say I've seen the amount of people that are willing to invest in solar panels has massively spiked in the last couple of years because of the cost of energy. When your payback is 3 years, not 15 years, that becomes a benefit for you, not a benefit for the next person to buy the house or wherever it might be. So I just think it's an interesting one where if you're looking at investors, you're looking at people on the top, it becomes a calculation. Is it better to reduce the energy of my building, or is it better to buy the offset?
A couple of times the topic of reclaiming materials was brought up, but it's actually quite difficult if a building was not built to be disassembled. So maybe that increases the risk, slows the process down, or makes it more complicated in general. So how can actually developers or investors be incentivized to do this?
I think that the first point you make there about sort of disassembly is key, that from the outset, if you've got this sort of modular construction about how can that be unbolted and taken away, then that has to inform the thinking of the new building.
I'd like to jump in there. I think the incentivisation is the fact that the embodied carbon of a reclaimed steel is, say, 50 kilograms per emitted tonne versus 1,740. So that in itself should be incentivisation to
Cleveland Steel, it was sort of categorised in terms of size, quality, and then the work that needed to be done to bring it up to standard to deliver to site. And also with a client that had sort of multiple sites that they were doing demolition at that time, then they were able to transfer steel work across. I think it's something we're seeing more of now. I think sort of Timber Square over the road from us is doing that as well. So there's certainly more of that happening.
There are now quite a number of suppliers out there that supply deconstructed steelwork, and we are already using that in a number of buildings. It's relatively simple to test that steelwork for quality. Steelwork for quite a number of years now should all have been stamped, and therefore that can be reused. And as I say, you will get warranties from those suppliers. Melting that down in an arc furnace, assuming that that's run purely on green energy, is also absolutely a viable solution.
It was a brilliant question you ask about incentivising developers, but there is that broader point, which the research shows again and again, is the viability of green buildings, and that ultimately tenants, those buildings and those landowners and developers and investors will attract tenants who wish to be seen to be greener and cleaner. So that value of that asset will be more in the long term. So I think it's always that CapEx versus OpEx.
Legislation, I think you do need a carrot and stick approach. We do quite a lot of timber frame buildings. We're actively designing timber frame data centres at the moment. We've done logistics buildings in timber and obviously all of the other sort of commercial uses that are probably better known. We're generally seeing cost increases of 15 to 20% over using traditional steel, composite concrete. And you've either got to legislate to require people and push them down a timber route, or you've got to be offering tax breaks for the timber framed construction to just make it easier for people to use that. There's no technical reason why you can't use those materials. I think one of the other thing that's changing is composite steel concrete is very efficient, but it's also probably the worst type of building to take apart. You've got all the studs on the steelwork, you've got to break that away from the concrete. The likely ability to reuse those steel sections is very, very low. So I think what we're lacking at the moment is the carrot that needs to go along with the stick.
Jonathan just touched on that briefly as well, the carrot and the stick. We do not wish to hinder new developments by making them less viable. However, funders will pull capital if there is no demonstrable transition to net zero. On reflection, effective incentivisation for the implementation of sustainable solutions is the way forward. We need a holistic approach with everyone on board, including the government, developers, insurers and designers.